Mr. Harris here, and welcome to a new video. In this video, we're going to continue talking about moles, and we'll be mainly focusing on doing some questions. So in the previous video, we learned about two formulas or two equations. Now, let me separate this into two. The first equation that we learned was our formula for finding the number of moles. The number of moles is equal to the mass over the molar mass. And for the second equation, we learned the number of moles of particles. So particles could be the atoms, the ions, the electrons, or the molecules. It'll be equal to the number of particles over our Avogadro constant, not avocado, Avogadro's constant, which is 6.02 times 10 to the power 23. Okay, now here I left some space here because actually you could sort of change the subject. So what if perhaps I want to make here, if I want to express this formula in terms of mass. So here, what I'm going to do is I'm going to put mass over here. Mass would be equal to what? Very simple. Imagine that the molar mass here, it's going to go to the other side. When it moves to the other side, it's right now it's divide. When it moves to the other side, it becomes times. So here, number of moles would be times by the molar mass. Okay, so these expressions, it will be better if you would know how to move them around, because later on it'll be easier for you to do the upcoming questions. And I'm going to do the same thing here. If I'm going to make the number of particles the subject, so I'm going to bring it down here, the number of particles, it would be equal to the same thing here. I can move my Avogadro's constant to the other side, it's going to become times. So the number of moles of particles times by my Avogadro's constant times 0.62 times 10 to the power 23. Okay, so now let's look at the first question here. We're asked to find the number of moles in 68 grams of H2O2. Now this is hydrogen peroxide for those of you that are interested to know. So you can see this is just asking us about the number of moles. It's not asking us to find the number of atoms, the number of ions, or whatever. It's just asking us to find the number of moles. So that's why I'm going to use the first equation here, which is this one here. I'm going to use the first equation. So let's load our equation here. The number of moles, that's what we're supposed to find, would be equal to, now the formula is mass over molar mass. What's the mass? The mass is given to us, and as I mentioned, usually the mass is in grams. This is the mass. So let's go ahead and write it down. This is the mass over the molar mass. What's the molar mass? The molar mass, we have learned, it's just the relative atomic mass added up together. So here, let me perhaps take a highlighter. Let me highlight this. We're just going to add them up using our relative atomic mass. So here, how many hydrogen atoms do I have here? I have 2 hydrogen atoms, and the relative atomic mass of hydrogen is 1. So 1 times 2. And remember, I said you're adding up the relative atomic mass. So you're adding up, that means you need to use a plus sign. So I'll put a bracket here. This was the relative atomic mass of hydrogen. And I'm adding up with oxygen here. Again, oxygen, how many atoms do I have here? 2. So the relative atomic mass is 16. 16 times 2. Okay, this is for oxygen here. And then go ahead and let's find our answer for this. The number of moles is equal to 68 over, then you take out your calculator and do it. 1 times 2 plus 16 times 2. So you should get that the number of mole is, perhaps I'll do it with you, 68 over, you should get, this is 34 at the bottom here. And finally, you get the answer is 2. And what's the unit? As I mentioned in the previous video, the unit is mol. Okay. So for this first one, this is the answer. Now, usually, if you have already expressed here, this is the number of moles, then usually you will not be really asked to write the unit. But just for the sake of getting into the habit of writing the unit, I'll be writing it for you. Now let's do the same technique. Let's do question 2 here. It says calculate the number of moles in 186 grams of H2CO3. And this is carbonic acid. Carbonic acid, it's a type of acid, and you'll learn more about acids and also alkalis and something called base in book 2A. This is carbonic acid. Okay, so here, you're only asked to find the number of moles. You're not asked to find any atoms. So you're just going to use the first equation. So let's load that equation. The number of moles would be equal to the mass, which is given here, 186, divided by the molar mass. The molar mass, you're going to just add up all of the relative atomic mass. Here, you have two hydrogen atoms. So 1 times 2. And then here you have carbon. You have 1 carbon only. So remember, and you're adding them up. So just 12. And then finally, you have oxygen here. And how many oxygen atoms do you have? You have 3 of them. So 16 times 3. There you go. And then take out your calculator again. Let's do it. It's 186 over, let me take out my calculator. 16 times 3, this is 62. Okay. And then what is 186 divided by 62? You should get, you should get a very perfect answer of 3 mole. Okay. Again, you don't really need to write the unit because you've already expressed that this is the number of moles. But here, just to make things simple, to tell you what's going on. So this is 3 moles here. And that is how you use the first equation. This is the mass, and this bottom here is the molar mass. Okay, now let's do in the next question. Now you're given the mole. You're asked to find the mass instead. So now we can, it's also asking you, technically it's also still asking you about the first equation. And remember I told you that we could express the number of moles in terms of mass. So mass would be equal to the number of moles times by the molar mass. So I just moved around the subject and made it into this. So now let's use this and to figure out what's the mass for the question. Here, you are not given the chemical formula. So you will need to figure out the chemical formula as well of aluminium sulfate. Aluminium sulfate here. So to find the chemical formula for this, first you'll need to know what are the charges on this. And aluminium sulfate, you should know this is a metal. This is a non-metal. Sulfate is a non-metal because it's SO4 2-. You should know that, and it will have an ionic bond and also a covalent bond actually. So now let's figure out its charge. So aluminium, the charge on aluminium, because it's in group 3, it's Al3+. And sulfate here, sulfate, you should be familiar in book 1B. You might be asked to memorize this. If I was a teacher, then I definitely told you to memorize it. Sulfate is SO4 2-. Okay, and then how do you find the chemical formula? The cross method. Yes, do that method. You take the number, bring it to the other side. You take the other number, and you bring it to the other side. But you write back down the original atom that was there. So Al now, you took the other number, that means it's 2. And then for SO4 here, SO4, what will the number be? Yep, the number is 3. But remember I said, if you just put the 3 there, it looks like 43. That doesn't make sense. So remember to add a bracket to it. All right, so aluminium sulfate would be Al2SO4. with a bracket 3. Okay, now let's try and find the mass. The mass, as I said, is equal to the number of moles times by, let me rub this part out, times by the molar mass. Now, the number of moles here, it's given to you. It is 0.076. And what about the molar mass? Now, the molar mass, now that we have the chemical formula with us, we can also figure out the molar mass. So the molar mass would be, for aluminium, there are 2 aluminium atoms there, and the relative atomic mass is 27. So 27 times 2. Okay, let me put a large bracket there so it's easier for us to do it. And then sulfur. How many sulfur atoms are there here? So there, you might say, sir, there's just 1. But don't forget, this 3 stands for that there are 3 more sulfur atoms there. Remember, it's going to be times here. This is times. So let's write it down. 32.1 is the relative atomic mass of sulfur, and times it by 3. And then finally, you have the oxygen. Originally, inside the bracket, you have 4. You have 4 of them. But remember, I said when it's outside the bracket, you're going to do times here. It's always times. So 4 times 3, we know it is 12. So we have 12 in total. We have 12 oxygen atoms. So plus 16 times 12. And we can close our bracket now. Okay, then, oh, this is rather long. So 0.076 times by, so if you take out your calculator, 27 times 2 plus 32.1 times 3 plus 16 times 12. You get this is 342.3. And then finally, what is your mass? Mass would be equal to 0.076 times by 342.3, and you would get the mass is roughly around 26.0. 3 significant figures. Now in chemistry, in the DSE, you don't need to always explain or specify that it's 3 significant figures. Now in it's already assumed in the chemistry DSE that it's going to be 3 significant figures. But one very important thing here is that you definitely need to write the unit. That's a must. So please remember to add back the unit. For mass, as I told you, it's in grams. So here, 26.0 grams. Okay, so this is the answer for question 3. Now let's move down and find one more for question 4. Calculate the mass of 1.3 mole of calcium nitrate. Now, first up, we need to see whether we are given the chemical formula. Obviously not. So let's see. For calcium, we know calcium is Ca2 plus. And nitrate, on the other hand, we know it is NO3 minus. Okay, calcium is in group 2. So actually all of those elements in group 2, they're going to have a 2 plus charge. All of those in group 1 are going to have a positive charge. So that helps you. Now, nitrate here, this one, unfortunately, you need to memorize for this. But for those that are in like group 1, group 2, group 3, then you sort of have an idea. Group 1, all of them are positive. Group 3, all of them are 3 positive. So do the cross method, same thing. Remember, you grab the other number, bring it to the other side. Grab the other number, you bring it to the other side. Now here, obviously, there's just number 1. And then you bring the atom down. You don't change the atom. Now here, the green colored one, there's no number there, right? So it's supposedly it's a 1 there, but we're not going to write it. And however, for NO3 here, NO3, which is nitrate, what's the number there? You see the number is 2. So bring the number 2 down. But it's not going to be 32. That looks weird. That looks ugly. We add back the bracket. So here, our calcium nitrate is CaNO3 2. So let's write it. This is CaNO3 2. Okay, now let's use our equation of finding the mass. So it's the same one that we did here. Mass is equal to the number of moles times the molar mass. mass is equal to the mole. So let's write it. Mass would be equal to the number of moles times the molar mass. Now this time, are we given the number of moles? Yep, we are also given the number of moles. You can see here, it is 1.3. So let's write it down, 1.3 times by the molar mass. So the molar mass of the compound. Calcium here, we can see it. There's only one calcium atom here. So here, I just need to write the 40.1 plus by nitrogen. How many do I have? Remember the bracket outside I told you, just times it. So inside I only have one nitrogen atom. Outside the bracket there's two. So 1 times 2, that means I have 2 nitrogen atoms. So nitrogen, the relative atomic mass is 14. 14 times 2. And finally, my oxygen here. Inside the bracket I have, here you can see I have 3 oxygen atoms. And the number outside is 2. So as I told you, you times it. 3 times 2 is 6. So 16 times 6. And close your bracket. So here, so this is equal to 1.3 times by, now take out your calculator again, 40.1 plus 14 times 2 plus 16 times 6. So you should get this is 164.1, the molar mass. And then finally, find the answer for this, which should be straightforward. You get this is 213. What's the unit? Yep, the unit should be grams. All right, so there you go. So here, what you have to do for the first equation here, this I use the first equation again, is that you need to know how to use the number of moles equation and how you can change it into mass. And the molar mass is just all of the atoms being adding up together. And if you see that the chemical formula, there's a 2 outside the bracket or a 3, then remember you're going to be using times. That's a common mistake that I see students making. Other than that, it should be fairly simple math. Okay, so I'll end this video here introducing how we could use the first equation. In the next video, I'll explain how we can use the second formula. So that's it for this one. See you in the next one. Bye.